Hello everyone, welcome to our today's session. We're gonna bring you introduction to Elyra and AI-centric extensions to Jupyter Lab. My name is Yiwen, and today I have my colleague here, Edward and Saishruthi. So before we get started, I want to give you a brief intro of us and what's our day-to-day job look like. I'm a data scientist and I'm part of the Kodi team. My day-to-day job is to create machine learning and data science use cases using our datasets. Over to you, Edward.
Hey everybody, my name is Ed and I'm also a data scientist on the Kodi team. I work on a few of our projects here at Kodi, including the Data Asset Exchange and the Model Asset Exchange.
Hello everyone, I'm Saishruthi Swaminathan and I work as a developer advocate and data scientist in Kodi team, and thanks for joining us today.
So just quickly before we dive into the rest of our talk, I wanted to give you all a brief overview of everything that our talk will cover today. So first, Saishruthi is going to give you a short summary of the many projects we work on here at Kodi. Next, Saishruthi will go on and give a deep dive into one of the two Kodi projects that we are showcasing for you today, and that is DAX, our Data Asset Exchange. Then I will introduce you to our second project, Alyra, which is a suite of AI-centric extensions for Jupyter Lab. Finally, Yiwen will give a demo showcasing how you can combine both of these projects, DAX and Alyra, to produce an effective and efficient AI workflow. And at the end of the talk, we'll also leave you with a few resources to get you started and up and running with DAX and Alyra.
Hello everyone. Now let's have a quick look at the Kodi team goals and projects. Kodi stands for Center for Open Source Data and AI Technologies. We are 30 plus developers and data scientists headquartered in San Francisco and distributed around the world, working towards contributing to open source projects. We contribute to both in-house as well as external open source projects and cover entire data science pipeline. As you can see in the image, we have projects that can help you in gathering your data till maintaining your model. So to connect artificial intelligence solutions to real world problem, you need people who can understand both AI and the problems you are applying it to. So in many industries, the only way to assemble both AI skills and industrial domain knowledge is to have a large cross-disciplinary team, and this fact makes it expensive, and it is also risky to deploy artificial intelligence application because you need someone with a business knowledge as well as AI knowledge to maintain it. So what is our mission here? So our mission is to address this problem by democratizing AI, which is to make AI technologies accessible to the practitioners that understand real world problems so that they themselves can develop AI solutions that can solve their business problem. So DAX offers high quality vetted data. By vetted, I mean we start by tracing the origin and merit of the dataset, learn about the usability rights and ownership. From here, we create standard metadata and perform internal legal review before releasing the dataset. And these datasets have clearly defined open data license, and we provide exclusive access to IBM research datasets that have played crucial role in building popular AI systems like AI Debater, entity recognition, and so on. Each dataset comes with tutorials that demonstrates the usage of data, and these tutorials can be directly exported as Watson Studio notebook or project. Next thing, we also provide data glossary to learn more about the attributes of the dataset, an option to preview the data to help users understand the data before using them. This will give them an overview of the data that they are planning to use in their application. Also, industrial use cases. We have created industrial use cases using the DAX datasets, and they are available as Cloud Pak for Data Industrial Accelerator. And you can directly take these accelerator and plug into your or use it in Cloud Pak for Data. I have listed all the resources in the slides that you can refer to and know more about it. So this is our DAX page. If you click on learn more, you will have a detailed tutorial of what is DAX and what we provide as a part of this project. So if you want to know more about the recent launches, like if you want to know about the recent releases, what you have added new. You can get into the what's new page. And if you want to connect with us, you can click on get involved, and it'll take you to this repository. You can start creating issues here and being one of our team members, and we'll be there to help you with your questions. So now I'm going to demonstrate to you all these features using two of our datasets. One is the PubLearnet dataset, which is one of our popular IBM research dataset. So first, let's see about the landing page. So this is the dataset. If you click on the tile, it will take you to the dataset landing page. The dataset landing page has a detailed and structured information about the data. First is the overview section. This overview section walks us through the dataset, what it is, right? What this dataset is about. So that information you can find under this overview section. Now let's get into the dataset metadata. Metadata section has details such as format, license, which domain does this dataset belong to, and how many data points we have. And let's say in your data you have them in different split, like a split for training your data, the split for validating and testing your data. So how many data points you have under each split. So those kind of information you can readily get from this metadata section. And you have information about the author, origin, and data coverage. Origin is nothing but where the data set is from, and data coverage is more about which areas in the specific domain does this data set cover. Also, we will end up with a business use case. So each data set is available in archive file. You can just click on get this data set to download the data set, and it's in archive format, it's in tar format, which you can untar and extract the contents. So the next I would like to demonstrate the data glossary and preview. So we have the button here, try the data set, try the data and notebooks. So you have the same metadata details here. So this is the preview page. We have previews tailored towards dataset format. This one is an example of image dataset, right? So we have provided a way for users to get a feel of how the dataset will look like. Here you have one of the images in the dataset with its related annotation. So on the left side, you have the image, and on the right side, you have the annotation. When you take this annotation and overlay on the image, which you are seeing on the left side, you will get the middle image, which is the annotated image. So the annotated image, you get it using the notebook. So if you want to know a way for visualizing this annotation, we have the notebook preview option here. So this notebook preview option, if you click on the notebook preview, it has instructions to download and extract the dataset and visualizing the data and to create models and so on. Now coming to dataset glossary. To understand your data better, we have provided data glossary, which is a list of terms with their definitions. Here, for example, you have images. So what this image contains, right? You have annotation, and you have different types of annotations, right? So if you want to know more about each term, know more about the know the correct description or the definition of the term, you get into the dataset glossary page. So as I've mentioned before, each dataset has assets associated with it. Asset can be either a notebook or a Watson Studio project. In this example, it's a notebook. So if you click on try this notebook, it will provide you an option for directly using this notebook under one of your existing Watson Studio project, or you can create a Watson Studio project and add this notebook to it. We also have some examples. If you see in our page, this is NOAA weather data. And if you click on run the dataset notebook, they're already available as Watson Studio project. So you can directly create a project here and all the assets are already into it. So you can directly start using it. CloudPack for Data is a fully integrated data and AI platform that helps modernize the way you collect, organize, and analyze data to infuse in artificial intelligence applications. We would like our users to know how these datasets can be used in solving a business problem, not just stop with model development, right? So we call these assets as industrial accelerator and can be directly used inside CloudPack for Data. So one example is this agriculture accelerator that I'm going to show. So it's loading. Yes. So the use case here is to monitor crop growth. Let me maximize it. Is to monitor the crop growth using a crop guide, which you're seeing here. And it provides timely alert to farmers about the weather change, possible development of crop diseases. You can see the list of disease here, evaporation of fungicide, and efficient use of solar panels, which is agri-voltaic support. This is basically a Shiny app. It is developed in Art Studio, and you can directly deploy this app and use it as a starter application. So this is one of the example of accelerator. We just don't want people, to just stop with the model development. We want them to actually know where they can use these data sets in solving a business problem. So yes, I have covered this part. So I hope you all enjoyed this DAX part, and over to Ed for Elyra part. Thanks everyone.
Thanks, Saishruthi. So let's now dive into Alyra. At its core, Alyra is a set of extensions for JupyterLab catered to people who like to work with artificial intelligence and machine learning using notebooks. Alyra's goal is to help data scientists, machine learning engineers, and software developers through the most common model development lifecycle complexities. If you'd like to access the GitHub repo or the docs for Alyra, you can follow the links we've shared here on the screen. Alyra was officially announced as an open source project by IBM this past April. Alyra boasts a host of features to achieve its goal, which we will discuss shortly. For now, notice from the preview Alyra's UI on the right here that Alyra doesn't radically reinvent JupyterLab to provide you with all of its enhanced functionalities. It simply extends the distinct JupyterLab environment that we've all come to know and love over the years with added tabs, toolbars, and launchers. So what can Alyra actually do for you? Well, you can really break down Alyra's core features into 5 items. The first, Alyra provides an easy-to-use notebook pipeline visual editor. Why build your next AI model using a pipeline editor? Well, it's because Alyra provides a simple, visual way to convert multiple notebooks covering pre-processing steps, experimentation, optimization, and deployment all into batch jobs or workflows. Second, Alyra supports running notebooks as batch jobs directly in the UI, making model training easier. Third, Alyra supports easy creation and insertion of reusable code snippets. This allows users to manipulate reusable pieces of code, making programming in JupyterLab more efficient by reducing repetitive work. Fourth, Alyra pipelines support Git version control, allowing rollbacks to working versions of the code, backups, and most importantly, sharing amongst team members. And fifth and finally, Alyra exposes Python scripts as first-class citizens. This allows users to locally edit their scripts and execute them against local or cloud-based resources seamlessly. Yiwen will now demonstrate all of these features for you in our demo.
Thanks, Ed, for the overview of basic functions of Elyra. So before I go into a live demo, I want to introduce you what is a pipeline. So a data science pipeline usually includes 5 steps, from data extraction to result interpretations. And let's think of this with the simplest example, such as a Python script. What you do is you typically read in some data, do something with the data, for example, machine learning or deep learning models, and then push the stuff you want to keep to a file system, or save it or output the files. And then run this on a scheduler or somewhere else. Elyra makes it possible to run Python notebooks instead. I mean, why running Python scripts when the Jupyter notebooks are so much easier? Usually the notebooks make things a lot easier to understand, it's more intuitive, and have each component to run together continuously and iteratively. It means you can always come back and go forward, you can delete some cells, and do whatever you want. It also makes it easier to tell the story behind the pipeline, and it might grow bigger as a project. You can think of this as a novel. In that case, we would like to break them down into smaller chapters, basically easier to maintain in the long run as well. It also brings in a benefit that if your notebook doesn't have dependencies on the prior notebook, it means you can run them parallel, or you can run them sequentially. Some notebooks might have different requirements than the others, like libraries, framework, file dependencies, environment configurations, etc. We want to make the pipeline eventually portable and shareable, so we need to take these factors into account. And we need to configure these for each notebook separately. We can run Elyra in containers, such as Kubernetes, and this will save time and save memories and GPUs because you can run things parallel, and workers can have different hardware configurations to accommodate various workloads. Clusters can also scale up or down, depends on your resource need. Also, if you need to change anything in one notebook, you don't have to rerun the other notebooks by clicking them through. Elyra will save your efforts by constructing them as a pipeline and run them all with one click. So now let's go into a live demo and let me show you how to run this. Also, there are several prereqs to run, so before we get started with Elyra, please check on the list, see if you have everything installed. Also, I copy-paste a few easy code snips in here. To install Elyra, you can run this in your local machine on your terminal, and also you can verify the installations. And after everything is complete, you can start the Elyra by running JupyterLab. And also feel free to check out the code on Elyra GitHub repo to clone, to fork, and also you can check out on the Elyra documentations. Okay, let's get into a demo. Now, let me walk you through a demo by running 4 notebooks using Elyra. I will introduce you 2 ways to run your pipeline, both on local machine and on Kubeflow pipelines. To build a pipeline, you can simply drag and drop the notebooks onto the canvas and connect them, just as easy as drawing a graph. You can arrange the notebooks in sequential or parallel order. You need to configure notebook properties for several informations. We put the environment variable dataset URL as a dataset download link from DAX. We copy-paste the link into a section. This notebook produced output files, so I specify the file name as gfkweather.csv, which is downloaded through the first notebook into the directory. The output files are uploaded to the cloud storage or saved in local directory after the notebook processing complete. We also need to select a Docker image that will be used to run the notebook. You can bring your own image or choose from the predefined public images. We choose pandas as a Docker image here because we mainly use pandas and NumPy packages in the notebooks. We could only select one Docker image each time. However, if you're running on your local machine, the image you choose does not matter. Also, you can declare the file dependencies as gfkweatherclient.csv, but this is not necessary since files are already in the same folder. I redefine the name of the pipeline by right-clicking my trackpad, changing the name to event.pipeline. Also, you can add comments to provide short descriptions. This helps your colleagues know the function of each node before going into it. Now, everything is all set. Let's save the pipeline and submit it to run locally. The running logs are shown in terminal. If everything completes successfully, a message will pop up. The run outputs will be shown in the notebook cells. See on the left side, the notebooks are just updated a few seconds ago. Now, let me quickly walk through the content of each notebook. Firstly, the load data notebook downloads, extracts the zip file through the dataset URL link, and save it as a jfkweather.csv file. The Part 1 notebook loads the dataset downloaded from the previous notebook, replace the round values such as none, t, 0.02, 0.01 second, filter out everything out of the range, converts columns to numerical types, clears out missing values, renames the columns, and then save the clean dataset as gfkweatherclean.csv file. The Part 2 notebooks select the 5 columns from the clean data and visualize the trend. Also, it explores the dependencies between the 5 columns. Then it visualized the trend of the rolling average in 2017. In the Part 3 notebooks, this explores the approaches to predict future temperatures by using the time series dataset. It creates training, validation, and test split, and then it trains the dataset and then compares the performance between different baseline models using the mean squared error. And it built a RIMA model predictions for the first 48 hours of the validation set. You can get the notebook on DAX page. By clicking on Preview Notebooks, you can see we have 3 notebooks very similar to what we have in Demo Pipeline. The notebooks were designed to run on Watson Studio and IBM Cloud. I made minor changes to the notebooks to fit this into the Jupyter environment. Now, let's submit and run this pipeline on Kubeflow. Before running, you need to configure a runtime by putting your credentials into each section. I already pre-configured my runtime, so now let's submit the pipeline on Kubeflow. In the run process, Elyra generates, gathers, and packages the required artifacts, upload them to cloud storage, and triggers pipeline execution in the selected Kubeflow pipeline environment. The pipeline runs are listed in the Experiments panel. The Graph panel displays the execution status of each node. You can see the Part 1 notebook is completed and has green checkmark at the right top. After the run is complete, you can access the pipeline's output artifacts using any supported S3 client. In here, we have all input and output files listed. Clicking on the data folder, which includes the JFK data file and the clean version. All tarballs are input files. By clicking on one of the output files and download, you can see the result of the notebook is saved in the output cells. So if you want to get involved with Elyra, please visit our GitHub repo and open enhancement requests or bug reports. Also, I copy-paste a few related links to our talk today, and feel free to check the bit.ly Pajamas-Elyra. We have our presentation listed on the link, and thank you.